we saved in 1 year moving to DevSecOps in DoD 3 years ago. We saved 100 years of time. First, because of the accreditation process, we have a very lengthy accreditation process. So we created the continuous authority to operate to be able to continuously assess the software, and we saved about 12 to 18 months of time per program, per 5-year cycle, just on the accreditation side of the house. And then, of course, with the continuous feedback loop, being able to continuously get feedback from the end user in production, not just in the lab, we're able to save another 4 to 12 months per program, per 5-year cycle. That gives us a $12.5 million cost saving per year per program, not even counting the time we saved. So you can imagine that's a massive amount of time and massive amount of money, saving pretty much 3 years, sometimes out of 5 years of plan time with each DoD program. If that wasn't enough to convince you, some of the numbers are pretty mind-boggling. You look at the faster mission delivery. We have 106 times faster lead time from development to deployment. We have 208 times more frequent code deployment, 7 times less change failure rate, 22% less time spent on rework, 50% less time spent remediating cyber issues, a mind-boggling 2,600 times faster recovery, specifically important to weapon systems, as you can imagine. We don't want the weapon to not work when we need the weapon to work. We see development costs reduced by 40% on average, so you can effectively do 40% more with the same amount of money. And faster prototyping enabled a 44% more time focused on new capabilities versus maintaining the legacy code. Of course, we have a tough time retaining talent like everybody else on the market right now. So we saw also employees being 2.2 times more likely to recommend the organizations as well. So as you can see with these numbers, it was pretty interesting for us to compare also a use case back in 2019 between SpaceX and F-35, the jet. SpaceX has 9 vehicles, F-35 has 1 with several variants. You have 200 developers for all of SpaceX back then and 4,000 for F-35. We saw about 50% defects rate per week on the F-35 side back then in 2019, which effectively meant that 2,000 developers were useless. And SpaceX was designed to be very modular using containers. And so what you see there is the ability to reuse code across the 9 vehicles back then, and 80% of the code was reused versus a very small 4% of code reused between F-35 and F-22s, for example. So SpaceX had the ability to do 17,000 build of software a day, 3 hardware-in-the-loop testing a day, which completely ran the entire software on the hardware to make sure nothing is getting broken with the new software update. And they were able back then to update software the day before the launch. So you can imagine the massive enabler that gives you DevSecOps to be able to update software literally the day before the launch, versus an average in F-35 between 1 to 7 years. So you can imagine that's not very good to be able to compete. So what we did in the first year is we took Kubernetes and Istio and we put it on the jet in 45 days, showing that we can run containers on the legacy hardware with Kubernetes and Istio and be able to move to modern languages like Java and Python and Go for something that used to run, C and assembly and stuff like that, and Ada. So that was a good first step to demonstrate we could do it on the legacy, 40, 50 years old platform. And then we made it the default for all of the Air Force and Space Force. So we started deploying on all the systems that we use. You can see here the U-2 Dragon Lady, the jet, also was effectively a 60 years old piece of hardware, we were able to deploy the Platform 1 DevSecOps platform that we call Big Bang, which is open source, by the way, on the jet in 12 days. We're able to put, of course, Istio on top with T-Trade and be able to build containers to manipulate and manage the sensors on the jet. So using AI and machine learning instead of the pilot having to manage the sensors manually while flying the jet. So it gives the pilot the ability to do something else. And we're able to fly the jet in 12 days with the new AI/ML capabilities with no impact to the airworthiness of the aircraft. But more importantly, we're able to receive over-the-air updates while flying with no impact also to the aircraft. So that demonstrated kind of the ability to decouple the flight control piece of the aircraft from the new software we bring to the table that has a faster deployment rate and more innovative features and not have any impact to the safety of the jet, very much like Tesla would do with their software over-the-air update as well. So that was a massive enabler, of course, and what that enabled us was to look at the containers and realize that we could reuse these containers and reuse the platform and accelerate the journey of all these teams to scale across thousands of people. The DoD is, of course, the largest organization on the planet, with 4 million people, massive, of course, amount of budget, and a lot of vendors and contractors, and that complexified the adoption. So we wanted to make sure the stack will be able to run on the classified clouds, on commercial clouds, at the edge, on different weapon systems like we talked about. So we decoupled the infrastructure layer and the platform layer. So as you can see, the infrastructure could be a cloud, a commercial cloud, edge system, air-gapped system, and we put Kubernetes on top. We support multiple Kubernetes distribution, so we have flexibility of options there. And then we put the continuous integration, continuous delivery CI/CD pipeline completely containerized using the Iron Bank hardened containers. Like I said, we have now 1,000 containers to pick from, 16 programming languages, 23 databases. So a lot of flexibility in terms of the tools. And on top of that, we brought the service mesh with Istio and T-Trade. So we're able to have a hardened service mesh that's complying with the FIPS crypto requirements. And so that gives us the ability to manage the traffic between containers. So container A talking to B has to be whitelisted, so that reduces the attack surface if a malicious actor get access or get a foothold on one of the containers. And so the beauty there is the platform and the service mesh are checking a lot of the boxes for the cyber controls that we have to implement to be compliant with the NIST cybersecurity framework, with the NIST 853 controls. So we're able to inherit about 90% of the controls at the application layer, so the microservices on top don't have to worry about all the basics of life of authentication, service discovery, and all these things that you have to do when you build microservices architecture. So as you can see on the left side, we also had a very strong cyber continuous monitoring capability using sidecar containers. And the beauty of the sidecar container was to be able to decouple the containers between the cyber side and the mission side. So if I have to update the cyber stack, I can update the cyber stack without having to coordinate across dozens of teams and have to figure out how to update the bits across dozens of hundreds of thousands of developers. So the sidecar is injected automatically by Kubernetes across the entire stack, and so we can update it with a push button deployment, but also we know it's going to run no matter what. And so even if teams don't think about cyber, we know we're going to get the cyber stack injected automatically into the stack using the sidecar principle. And what that does here is we have multiple capabilities. Of course, we have the service mesh with Envoy, the reverse proxy to do zero trust enforcement, inject a mutual TLS tunnel to do authentication and encryption in transit. But then also we have the ability to continuously monitor the logs and all the telemetry of the application and push all these logs to a central place. And so that was a massive enabler to get access to all the data, but also to be able to enforce the desired state and look at the behavior of the containers, and if they start doing something they've never done before, we can kill them every time that shows up. So we also have the principle of moving target defense. Moving target defense is a concept where you treat your entire stack as cattle. So cattle versus pet. The concept is to say, a pet is a virtual machine. You give it a name, you care for it, you don't want it to die, you heal it when it's sick, and so that's outdated. We're moving to the cattle concept, which is really initially started with containers, but now your entire stack could be cattle, and so the concept is to shoot it behind the barn every 4 hours and move back to immutable state. So if a malicious actor got access to some of your containers every 4 hours, they lose everything they've done, so it's harder for them to retain their footprint inside of your network, but it's also harder for them to laterally move to something else because they have to restart from scratch every 4 hours, but also with the Zero Trust service mesh enforcement, you cannot laterally move to the entire stack, so it's difficult to get to the crown jewels of your application. So that is kind of the cyber stack we ended up building there, and that gives us a lot of flexibility to enable teams not to have to worry about all these things. So as you can imagine, having to train 100,000 people and kind of educate on all these different things, service mesh, moving target defense, and all the cyber stuff we talked about is complex. So we partnered with the Linux Foundation and the Cloud Native Computing Foundation and O'Reilly, the publisher. And so we created curriculums that you can find here on the software.dev.mil website/training. We also gave an hour a day to our people to learn. So if you're not doing this, do it for yourself, invest in yourself, make sure you can keep up with the crazy pace of IT. So we definitely recommend taking an hour a day to learn. Ideally, your company will give you some time too, but even if the company does not give you time, you should take it anyway and invest in yourself. Don't wait for somebody else to do that. And then we push the right certifications, of course, with hands-on learning, so we know for sure that people are capable. If you look at the cyber certifications, it's very easy to read a book and go answer a few questions and get a CSSP or Security Plus or CEH or whatever, right? But these certifications are hands-on and you can't cheat. So you can't just read a book and pretend you know how to do things. You have to do it in actual exercises. So with the CNCF, Certified Kubernetes Application Developer, Certified Kubernetes Security Specialist for Cyber, and Certified Kubernetes Administrator, that is kind of the three great CNCF certifications. And then, for people moving to the mesh, which is essential to be able to succeed in moving to microservices, T-Trade also has created the Certified Istio Administrator certification as well. So that gives you a lot of flexibility to go and learn and make sure that you can keep up with what's going on in the DevSecOps community as well. So for people that want to know more about everything we've done, we open sourced a lot of the content. So you're going to find on Repo One, all of the Platform One work is open source. We have a lot of great demos and the ability for you to effectively replicate the entire DevSecOps platform that we built in DoD. It's the largest contribution to open source by the US government every year. We also have a show every Tuesday at 1 p.m. where we bring guests, and it's 1 p.m. Eastern here in the US, but that would be 7 p.m. in Europe. So that gives you a new guest every week where we talk about culture and cyber and tech and different things. We have the latest videos also with all the publications, architecture documents, and training also on the software.dev.mil/dsop/documents. And like I said, the repo1.dso.mil, that's where the source code is of all the source code we have. And the Iron Bank is the container repo where you can download all the hardened DoD containers. So if you want to use them, it's open source, and you can just go and get access to all these containers. So with that, wanted to thank you. I know it was only 20 minutes, so I had to rush through this, but again, we have recorded videos and way more content on the website if you want to see how the DoD took Kubernetes and Istio and saved 100+ years in 1 year moving to DevSecOps. Thanks for having me today.